Alright, this lesson is a review of a few concepts. We learned to solve proportions, which look like this. The goal of that was really to be able to work with similar shapes and triangles and be able to solve them. This lesson will include similar triangles and shapes. And also, we've been working on special right triangles, 30, 60, 90 triangles, and 45, 45, 90 triangles, and the patterns that we see with those triangles. So this lesson is a review. We have a test tomorrow, so this is a review lesson. Okay, number one, solving proportion. Of course, we cross multiply by doing this. That's going to give me 2x from this diagonal. 3 times 4 is 12. So x is equal to 6. On this one, if I do this diagonal, that's 3x. If I do this diagonal, that's 30. So 3x equals 30. So x is equal to 10. Okay, looking at number 3. Are the triangles similar? If so, state the theorem and state the similarity. Well, what we need to do is set up a proportion. If we have indications, we have markings for two sides and an angle. Two sides and an angle. So there's a possibility that this will be side angle side. We have to make sure that the sides are proportional. So if the sides are going to be proportional, these are going to need to be corresponding sides. They both have the x's in them. And these will need to be corresponding sides. So let's make fractions out of these two and see if we get the same number. For example, let's start with the blue, since I already have that color going. 4.5 over 2.25. Alright, let's just put that in the calculator. Okay, 4.5 over 2.25. Okay, that's 2. Okay, now let's do the red. Alright, if we do the red, that would be 2x over x. This one over this one. Well, of course, these x's are going to cancel out, and I'm going to get 2. So the sides are proportional. So that's side angle side. So there's my theorem. So I will say yes because of side angle side. That's what I mean by theorem. And now we need to state the similarity. So don't forget this part. So this is triangle GHI. So that's GHI is similar to triangle. Now I have to make sure these match. So G, see how it's next to the red? That's going to correspond to K. So that's going to be KJL. Okay, now looking at number 4, anytime I see this sort of bow tie or hourglass shape, I think about the fact that these are vertical angles, and vertical angles are always equal. So we've definitely, we've got that. Also, okay, we haven't talked about this in a while, but you see these parallel lines? Of course, that's what these make. When you have a parallel line with a transversal, a line traveling between the parallel lines, it forms a Z. Remember, we used to talk about Z angles sometimes? So let's see, look at this. I'll use orange. Look at this Z that I'm about to draw. It goes like this, and then this, and then this. Alright? When you have parallel lines, you can look at them as the bottom and top of a Z. The transversal is like the transversal of a Z. So the corners of the Z are always going to be congruent. All right, these are called alternate interior angles. Okay, but they're the angles in our Z. So you can see that we have two angles that are congruent for both triangles. And that's all we need to say that yes, these triangles are similar, and that'll be angle-angle theorem. So it's time to state the similarity. So I'm going to say triangle MON, for example. You really can start this off any way you want. Similar to. Now we have to be very careful with the next part though. M corresponds to angle Q, so I have to say Q next. Of course, O corresponds to itself, and that leaves angle P. So triangle QOP. Okay. Now looking at number 5. We have one pair of angles right here. Okay, the two triangles that we're looking at, I hope you can see it, are the small triangle that's right here, but then there's the big triangle that's right here. Okay, those are the two triangles we're talking about, like the blue triangle and then the yellow triangle. But both of those triangles share this angle at V. So far they have one angle in common. Now because these lines are parallel, these corresponding angles will automatically be congruent. When you have parallel lines that are cut by a transversal, corresponding angles like this one and this one will be congruent, as well as these corresponding angles. Okay, and when you have two parallel lines, the corresponding angles are always equal. So really all three angles are congruent, but we only needed two, so we're going to go ahead and say yes, these are similar, and again it's because of angle-angle. Notice we weren't given any sides at all. So let's go ahead and state the similarity. So triangle, I'm going to say UVT like that. Okay, I didn't have to start that way, you can start any way you want. But now, since I said UVT, I have to say RUS. I mean V, not R, not U, RVS. Okay, make sure those letters match up. The U corresponds to the R, so the U must be in the same position as the R. Okay. Let's see. For number 6, we are told that the triangles are definitely similar, so we just need to find the value of x. Okay. So look, please understand that we're talking about the smaller triangle and the bigger triangle. So let's look at the smaller triangle. Is this triangle, of course. Alright, but then compare that to the bigger triangle, which is going like this. Okay, so we're looking at the small triangle and the big triangle. So looking at the small triangle, we have the 15, and that's going to correspond with the 20 on the bigger triangle. So that gives us one fraction, 15 over 20. Okay, so we're doing small over big right now, 15 over 20. Uh-oh, okay, this is going to be tricky. Okay, alright, you know what, this is, we haven't really done one very much like this before. So this is going to be a little tricky for you guys to understand. We need the length of this small side, or maybe not the length of it, but an expression for it. so we can put this in our ratio, in our fraction. But we don't have one. So what we need to do is, look, if this whole thing is 17, and then this little piece over here is x, what that means is the other piece, I think I'll switch to red, this piece over here we could look at as 17 minus x, because the whole thing is 17, and if we subtracted the x, we would have this part of the triangle. So this part of the triangle is the whole thing minus x, so 17 minus x. Okay, so that's the trick, is understanding that if you have a whole thing, if part of it is x, the other part is going to be 17 minus x. So that's what we're going to need. All right, so when we do small triangle over big triangle, it's going to be 17 minus x over, and of course the big triangle is this 17. So 17 minus x over 17. Now I have a feeling I just lost a few people, but maybe we'll practice that again at the end of the lesson. So then it's just a matter of solving this, which is the easy part. So if we cross multiply now, okay, so if I do this diagonal like this, all right, in fact, let me show my work this time. So this would be like 20 times 17 minus x equals, and then if I do this diagonal like this, all right, talking about 17 times 15. All right, so if I do a little distributive property here, let's see, it's 20 times 17, it's 340. So this is going to give me 340 minus 20x. Okay, and this is going to give me 255. If I subtract 340 from both sides, that's going to give me negative 85. So I have negative 20x equals negative 85. So I need to divide both sides by negative 20. All right, so that's going to give me, okay, for a second there, I got x equals 4.25. Okay, but this is not a real world problem, so let's not leave this as a decimal. So I hit my toggle button, so you know I got 4.25, but if I hit my toggle button, I'm going to get 17 over 4, so let's use that. Okay, so x is 17 over 4. All right, that one was a little bit tricky, especially that 17 minus x part. We'll review that little concept one more time at the end. Okay, back to easy stuff. So solve for x. This is a 30, 60, 90 triangle. All right, so the pattern goes that this is the short, this is the long leg over here, and we will label it short radical 3. And of course the hypotenuse, we will label that 2 short. Okay, so if I want to find the short leg, I can just divide by 2. So divide by 2, divide by 2. That's going to give me that the short leg is 12 millimeters. Okay, so boom, that gives me that x is 12 right there. So x equals 12. Okay, But if I also take that short being 12 and put it right here, that's going to give me 12 radical 3. But I guess they didn't really ask for that. But so x equals 12 is the answer to this particular question. This one's super easy. We know that it goes leg, leg, and then leg radical 2. So since the leg is 12, that makes this 12 radical 2. Okay, but you knew that. And on this one, it looks like they're asking us for the altitude here. Okay, we're being asked to find this line right here. So we're just focusing at one side of this triangle at a time. Okay, so we're not looking at the whole triangle. We're just looking at this side of the triangle. Okay, so focusing on that. Again, let's see, let me blow this up a bit. Okay, so this is just going to be, this is the short leg, this is short radical 3, and this side is 2 short. So 2 short equals 3.8. That means it's time to divide by 2 on both sides. Okay, so that's going to give me that the short side is, let's see, 3.8 divided by 2. The short side is 1.9. Okay, so that means this is 1.9. Which means that this is 1.9 radical 3, which is what we're looking for. So I could put 1.9 radical 3, but if I do not want a decimal, I can just use my calculator to convert that. So 1.9 just hits your toggle button. So that's 19 over 10. So I could call this 19 over 10 radical 3. Or I could have said 19 radical 3 over 10. That would have been the same thing. Okay, so that's x. All right. Okay, I guess we're down to the last problem, number 10. All right, in number 10, we have a symmetrical canyon. That means it's the same on the left and the right, perfect balance. And the numbers are given with the degrees. So find the distance across the canyon. So we are trying to find this distance right here. That's what we're looking for. Okay, so if we can find the short leg of this 30, 60, 90 triangle, then we'll just double it, and that will be the distance across the canyon. By the way, you see this 60 degrees right here? That means this is 60 degrees over here, which means this is 60 degrees down here. This is an equilateral triangle, if anybody cares. All right, all three sides, the distance across the canyon and the canyon walls, they should all be the same length. Anyways, 4,500 feet, that's this altitude. Okay, now this is the short leg, and this side, the hypotenuse here, is what we always write as 2 short. Okay, double the short leg. But this is the one we really need because it's the only one that has a number on it. So this should be equal to short radical 3. So this is the one we have to work with. So of course we are going to divide both sides by radical 3. So divide by radical 3, divide by radical 3. Alright, this should give us the short leg. So 4,500 divided by radical 3. Okay, so it's not going to give us radical form this time, which is fine because this is a real world problem. So we have 2,598 with some decimals, 0.1. So 2,598.1 is equal to the short leg. Now, if possible, I'm going to try to save these decimals. I don't want to lose them until the very end. But anyway, that's the short leg. Okay? So remember, what we are looking for is the distance all the way across the canyon. So that's going to be double this. So what we really need is 2 times the short leg. Okay? So 2 times this number. We need to find out what that is. So this is why I'm glad that I saved this number with all of its decimals, because if I want to double it without losing the decimal places, I can just hit times 2 right now. So this is the answer that I want, 5,196.2. feet. Okay, so never round until the very last step, like I just did. So that's the answer to part A. Maybe I should have written it up here. So 5,196.2 feet. Okay, find the length of the canyon wall. Okay, so at the beginning of this problem, I talked about the fact that this is going to be an equilateral triangle. So this is also going to be 5,196.2 feet. Okay, and it just makes sense. I had to double this. That was 2 times the short leg, but then the hypotenuse is always 2 times the short leg as well. So it makes sense that those be the same. Now, is it more or less than a mile across the river? Well, a mile is 5,280. This is only 5,196.2. So clearly that's less than a mile. All right, and that is it for this review. Okay. I just want to practice one more time with that thing. Let's see. That thing about, let's see, just give me 1 second. All right, I'm making some similar triangles here. All right, so these triangles are similar. Now, I just want to practice this concept. Remember up here where I did the 17 minus x? I want to practice that one more time. So I'm just making up this problem right now. But let's say I told you that this side of the triangle was, I don't know, 30. Okay? And let's say if I told you that the other side of the triangle was 75. Okay? Now, what if I told you, let's see, let's say this side of the triangle was, all right, what if I told you that the big side of the triangle over here was 100? And so I'm talking about all the way from here to here. Okay, so again, this is just an extra bonus problem. Let's call it number 11. Okay, and say if I gave you this x right here, and I asked you to find it. How would we do that? Okay, so let's make our two fractions, and we need to do small over big. So looking at the small triangle, that's 30. Okay, so the small triangle has the corresponding side of 30. The big triangle has a side of 75, so I have 30 over 75. Now, if you were not careful, you would do x over 100. Now, 100 is definitely another big side. But x right here, x is just this. All right, that is not the side of any triangle. What we really want is this part up here. Okay, this is the small side. This is the corresponding side of the small triangle. This is what we need to put in the top of this fraction. But do you remember what I can write for this side of the triangle? If the whole thing is 100 and this part is x, what expression can I put right here for this part of the triangle? Okay, I'm hoping you said 100 minus x. Okay, if the whole thing is 100 and I know that this piece is x, then the other part will be 100 minus x. That's how it works. Okay, so I could sit here and do 100 minus x over 100, and then I could solve the problem from there. Okay, but that was the key. All right, let's practice that one more time. Okay, last time. I'm going to call this number 12. How would I set up an equation for this problem? Okay, of course I'm going to make a fraction out of the 12 and the 18. Alright, I'm going small over big. Alright, using this side over here, small side, big side, of course the big side is 21. But again, for the small side, am I going to put x up here? No. X is just this down here. That was terrible. X is just that part down there. I need this part up here. So what am I going to put to represent this small part of this side of the small triangle? And hopefully, once again, you said that's going to be 21 minus x up there. Alright, if the whole thing is 21, if this part is x, the other part would be 21 minus x. So I would go 21 minus x over 21. Alright, that's the part over the whole equals the small over the big. And then I would solve it from there. Okay, so you can stop watching now, but I'm actually going to go back to the one I called number 11, and I'm actually going to solve it and find the actual answer, just in case anybody was curious. Okay, so I'm going to go ahead and solve this. So what shall we do? You know what, first I like to reduce this, so 30 over 75. So 30 over 75, that's 2/5. Okay, so this is going to become 100 minus x, and no, I cannot cancel out the hundreds. You can't cancel out anything that's connected with a minus sign or a plus sign. Okay, 100 minus x over 100 is equal to 2/5. So if I cross multiply, okay, that's going to give me, if I do the 2 times 100, of course that's 200. If I do my 5 times 100 minus x, I'm going to get 500 minus 5x is equal to 200. If I subtract 500 from both sides, I'm going to get negative 5x is equal to negative 300. If I divide both sides by 5, I'm going to get 60. Okay, so for number 11, x was equal to 60. All right, now that's really the end of the lesson.